Okay, so now we're looking at elimination. It's another method to solve a linear system or find the point of intersection. And it's where we're eliminating one of the variables and solving for the remaining one. In substitution, you are substituting in the expression of a variable and then simplifying for the remaining variable, whereas in elimination, we're going to add or subtract the lines to get one of the variables to disappear. So if we look at example 1, we can see that if we add straight down, our y's are going to eliminate. Okay, so we eliminate our y by adding straight down. We get 2x equals 8. We can solve for x by dividing by 2 and getting x equals 4. We can then substitute that value back into one of the original equations, either into x plus y equals 6 or into x minus y equals 2, and solve for y. So subtracting 4, we get y equals 2. Here we can either subtract 4 and then divide by -1, or we could add a y and subtract a 2. Either way, we still get the x value of 4 and the y value of 2. Now, what you have to be careful of is sometimes we need to multiply one or more of the equations by something in order to get a common coefficient so that we can add straight down and eliminate a variable. So we can see here that by adding straight down, we won't be able to eliminate either of our variables. If we multiply the second equation by a -2, though, our x will become a -4x for the coefficient, and they would eliminate. If we multiply the second equation by 3, we would end up getting -3y, so that when we add straight down, the y's eliminate. So you can see that we can use either method. You're not doing both. You're either eliminating x or you're eliminating y. So in either scenario, you can see that our first equation stays the same. We're just multiplying our second equation, the entire equation, by a constant. So when you do that, now we can add straight down. Our x's will eliminate, and we're left with 5y equals 10, divide by the coefficient of 5, and y is 2. If we eliminated the y and added straight down, we would get 10x, eliminating the y. 6 plus -6 is 0. Divide by the coefficient of 10, and we get the x-coordinate of 0. Once you have your one value for your variable that remains, you can plug that value into one of your original equations. So here we substituted in 2 for the y into the first equation and solved for x. Here we plugged in the x value of 0 into the first equation, and we solved for y. In either method, eliminating y or eliminating x, we got a point of intersection of 2. So let's try a word problem. Leslie sells baby blankets. Her softy blankets sell for $35 each, and her satin cuddle blankets sell for $20 each. At the Toronto Trunk Show, she made $460 and sold 17 blankets on the first day. How many of each did she sell? So we have a word problem. We don't have our variables defined, so we need to do a let statement. So I'd like you to pause the video and write your let statement of what you're looking for your unknowns. Okay, so you should have your unknowns are the number of softy blankets and the number of cuddle blankets. You can use S and C, you can use X and Y, as long as you have your let statement. Next, you want to come up with your equations. So pause the video and write your equations and then come back. So you should see that you have your $460 is going to come from your value in both amounts. Your 17 blankets is going to come from the sum of each blanket. So you could use substitution, but we can also see that we can eliminate by simply multiplying the second equation by a constant to get the same coefficient but a different sign for each of our variables. Okay, so you can choose which one you want to eliminate. And the key thing is that if you have your variables on the same side or in the same arrangement in both equations, it's easiest to use elimination. So you could eliminate S by multiplying the second equation by -35, or we could eliminate C by multiplying the second equation by -20. So let's do the nice even number of multiplying by -20 and eliminate C. So when we do that and we add straight down, we end up getting 15s is equal to 120. We divide by the coefficient of 15 and we get s is equal to 8. You can then substitute into either of your original equations. It's easiest to go into the one with coefficients of 1, so we'll be subtracting the s value and getting c is equal to 9. So word problems mean you need a therefore statement. Leslie sold 8 softy blankets and 9 cuddle blankets. Again, if you have a let statement, you need your therefore statement. So that concludes day 1. You can come back and visit this video for day 2's 2 examples. So if we look at day 2, we can see that we are now dealing with linear systems that have decimals. You can get rid of your decimals by multiplying by constants of power of 10. So we can multiply, since it's one decimal place, by 10 in both scenarios. By doing that, we get nice integers as our coefficients. 2x minus 3y equals 26, and 4x minus 7y equals 31. We can also see that if we want to use elimination, both our equations may need to be multiplied. Looking at this again, there's nothing that we can multiply the first or second equation by to eliminate y without doing it to both equations. So let's eliminate x by simply multiplying the first equation by a -2. When we do that, we don't change our second equation and we can simplify. So we end up getting 2x plus 6y is going to equal, sorry, that's a typo. Okay, now we can see that when we add straight down from having our things multiplied out, again, we still have another typo, hang on. Okay, now it's all fixed. So now we can see that we multiply -2 times the 2x, we get -4x plus 6y, and then the -2 times the 26 equals -52. So when we add straight down, our x's are eliminated. We get -1y is equal to -21. Dividing by -1, we end up getting that y is equal to a positive 21. We can now take that value, plug into one of our original, and we can go into our factors of 10, and we can simplify and see that we end up getting 2x is equal to, moving the 63 to the other side, 89, so x is 44.5. So therefore, our point of intersection is 44.5, 21. So again, you won't necessarily get nice integers. All right, let's look at a final example. Henry sharpens skates at a local arena. He charges $3 to sharpen a pair of figure skates and $2.50 for a pair of hockey skates. Last Saturday, he earned a total of $240 while sharpening 94 skates. How many of each type? So I'd like you to pause the video and come back when you're ready. So you should have your let statement of F being the number of figure skates, H being the number of hockey skates, and have your two equations, F plus H equals 94, and the dollar amount 3F plus 2.5H equals 240. Eliminating for F or for H, you're going to have to multiply the top equation by a coefficient. So we can eliminate F by multiplying the top by -3, and then see that when our F eliminates, we get -0.5H is equal to -42. Dividing by -0.5, we get H is 84. Plugging back into the original, we get that F is 10. So finally, in your therefore statement, Henry sharpens 10 figure skates and 84 hockey skates.